to quickly introduce the lecture, which I'm pretty excited for, it will be, let's say, revolving around plywood structural systems and modular solutions. A series of plywood structural system, bespoke flat pack furniture, and modular solutions for contemporary cities. A journey through the exciting world of digital fabrication and the manufacturing of joinery details and prototypes, which I believe is very fitting, let's say, for the situation that we're in. Especially when we're talking about rethinking spaces within a larger space, how we can provide safer spaces, more partitions, or even spaces within open air. A quick introduction to Tommaso. We have his partner also, Jonas, but he's hiding right now. So Tommaso, I had the chance to meet Tommaso, obviously, almost a year, I want to say a year ago. And he's one of the founding directors of a London-based architectural design and manufacturing firm. The studio adopts a creative and hands-on approach as a strategic tool to propose design solutions to the contemporary world. Tommaso studied architecture and graduated with honors at the University of Genoa in Italy. Excuse me. During his career, he worked in various international architectural and multidisciplinary practices such as Ensamble Studio, Studio Seilern, probably completely butchered that, BDP, and Allies and Morrison. So if you guys are familiar with Allies and Morrison, to the people in Amman, they're the master plan consultants who are working on Hayy al-Arfan. He has been a lecturer and a speaker at IUAV, which is the Architectural Institute in Venice, Italy, Leibniz University in Germany, and Architecture Foundation in London, as well as FORMA. Some of their memorable or quite impressive projects that they have worked on is Minima Moralia and London Festival of Architecture, Quayo Box in Milan Design Week, AIDA in Dubai Design Week, and part of the Unfolding Pavilion during the Venice Biennale of Architecture 2018. And of course, the Arches Project, which is the one of the finalists at the Building of the Year Award 2020 by Arc Daily. So this is a very quick introduction to Tommaso. I will hand it over to him to start the talk. As I mentioned before, to all of the attendees, if you have any questions whatsoever, the Q&A is either in the bottom or the top, depending if you have it as full screen or not. And yeah, so I'll just hand it over to you and you can share your screen, Tommaso, and take us on this journey.
Yeah, thank you, Mariam. I hope that everyone can hear me well and see me well. My name is Tommaso. I'm one of the founding directors of Boano Prišmontas. I'm sorry that all the names of our projects and our firm, they always sound difficult. But yeah, that's our name. I founded this company with Jonas Prišmontas in 2015. And since then, we've been working on a wide range of different projects. And we started with like standard, I would say, architectural projects. And then we slowly shifted towards manufacturing because especially when we started, it was difficult to kind of self-fund projects that could be built by a big team of people. So we ended up learning how to manufacture things and how to build our projects ourselves. And I would say that this kind of shaped our mind and our way of doing things. And to the point that I'm talking to you right now from our workshop. As you can see here, there are lots of tools and there's plywoods, and this is the place where we prototype things. And we always stress how key it is to not only design projects, but also prototype details, or make sure that construction sequence works well as design process goes. You know, like you need to make sure that whatever you sketch at some point has to be built by someone, so it has to work well. Yeah, I'm actually showing you some of the tools that we have here, just to give you an idea of what we think like an architectural practice nowadays should do. It's not just about design, but it's also about making. So sorry for the mess, but this is our CNC where we cut plywood mainly, and this is our big boy, our robot. So we have a 7-axis robot that is very useful to create 3D elements and work on formwork. We designed different structures that needed sort of like a 3D, like it's a 3D tool to build. So that's why we need the robot. Sorry, I dropped the cable. Here we go. Sorry for this. Okay, I will start this webinar by like bringing you through a journey, as Mariam said, a journey through 3 different projects that are very important to us, and they kind of defined the way we work now. And I will share the screen, and I hope that you can all see the presentation. There we go. There we go. Can you see it? I hope so. So the first project that I want to tell you about, yeah, and I'm gonna skip this. This is basically saying what we do, but I just said that. The first project I want to introduce you is a Quivox. Is a project that we designed and built in 2017 for Milan Design Week. Actually, this project started a bit earlier, following a trip in Colombia, where we experienced how the level of the sea was rising every day, following climate change and all the problems of climate change. So we were in this little village in the coast of, in the Caribbean coast of Colombia, and we were working with the local NGO to trying to define a master plan together with Architects Sans Frontières, trying to define a master plan on how to relocate a number of houses that were built on the beach or on the front, basically. And these houses at 3 in the afternoon were like flooded every day because of the rising of the sea level. So following this experience, we kind of wanted to help and create something that could really make a drastic change. And we wanted to design a portable workshop that could be placed on a floating platform. And we wanted to sail this platform through the mangroves and through the on the coastline to reach all these different villages, and use this workshop as a way to teach to the local people how to build in a different way and what the problems of climate change will actually entail. And so we came up with a structure that had to be modular because we had to ship it there, and had to be easy to build. And also we wanted it to be like a sort of a manifesto of a new way of building. 1 year later, we were in Milan, and Milan Design Week loved the project, and they asked us to build it and to position it not on the water, but in the center of the square in Tortona district. This is the front, where you see that it kind of worked as a half public space and half workshop. So we wanted to be able to close it off completely or open it to allow people to step in and see how things were made, how things were built, and how to and basically learn how to build houses in a different ways. The entire structure is modular, meaning that is made by a series of frames that are joined together by just using plywood. We wanted to use plywood because it's it's a great material. Is sustainable. You can cut it with extreme precision with the tools that we have here, and also you can send it everywhere in the world as a flat pack. Obviously, if you work with the northern countries, you might end up using different kind of plywood, which is probably, I don't know, birch plywood. But if you work in the southern countries, you might choose, you know, local species to still build something that is local. But like the fact of using plywood is incredibly good to create modular structure. The structure that you see here doesn't have any screws or nails or glue. Everything has been built by slotting pieces of plywood together to create this system that is entirely based on dry joinery. You can see in the video here that every single piece had to be built in 3D, tested. We did a prototype on a smaller scale, and then we had to build it in Milan in just 2 days, because usually when you work on this sort of a project, you don't have a long time to design things and then make them and then test them. No, everything has to happen now, because you have 2 days to build it up and 1 day to take it down. So we spent a bit of time understanding the sequence of how every part was built and put together, and then we just had to improvise it there and do it for the first time actually at 1-to-1 scale. Obviously, the key of these kind of projects is having a good team, a team of people that are open-minded and they're happy to test different ways of building. And but we had a lot of fun. I mean, like building something like that, it might be a lot of work, but in the end turns out to be faster, quicker, and it's kind of like a thing that brings the team together. Yeah. So this is one of the prototypes. Sorry, this is one of the modules of the structure that you've seen in the square, and we built one inside as part of an exhibition. Again, you see that every single joint is without screws or nails. It's just like pure dry joinery technique. And the size of this element is like 3.6 meters by 5, and it didn't have any column in the middle. So our engineer was a bit skeptical, but we kind of convinced him that we could do it. And yeah, and we built it with the zero tolerance, meaning that all the pieces to slot in to have to be extremely tight. So one of the challenges is actually understanding what is the right tolerance for each piece. And that's why prototyping phase is one of the key phases of the process. You see here 2 different joints. This is on the left is the joint that like holds the 2 parts of the building together, and the one on the right is the typical joints that's with a series of C shapes kind of sandwich the structure together. Yeah. Another project that I want to present today is the Arches project. The Arches project is a project that started in 2017 with a competition launched by the Mayor of London, Lambeth Council, and Meanwhile Space. Meanwhile Space is a company that kind of that operates spaces, creates affordable spaces for local startups, businesses, and the subject of this competition was basically creating a system, a kit of parts that could be easily built to retrofit arches that were not in use. So in London itself, we have up to 3,000 arches that are not in use. They're not in use because they are too damp, they are too cold, they're simply, you know, not in a great state. And at the same time, you have so many other arches that are filled with laboratory. I don't know, like there are carpenters, there are all sorts of like people that like make things, you know. So we were very happy to work on this project because we felt that we were creating space for people that often now struggle to have a space where to make things, yeah. So you see there are arches of all different sizes and shapes. I mean, shapes is always an arch, but like some are deeper, some are on 2 levels. And what we presented to Minimal Space and was a system of parts made with plywood that could approximate the curvature of the arch. And in this way, it could be used to retrofit arches of any shape and any size. This is one of the photos that show how the arches were when we started working. This is actually already cleaned. When we stepped in for the first time, the arches were full of leaves and cats and rubbish. There were, I mean, all sorts. But with our project, then in a bit of, I mean, after building the structures, like in a couple of weeks, you can turn an abandoned space into an asset for the city and for the local areas. The vision that we had was something like this, where all the arches were quickly infilled by our structure. And then we wanted to create space for startups, businesses, and anyone that was in need of a space where to make things or where to create. I will show you a physical model here, actually. Stop the sharing of the screen for a second. I hope you see me here. Yeah, this is one of the models of the arches and the structure that we made. I'm showing you this because it's kind of key for us to test every project, not only as a, well, I mean, with the 3D or with the drawings, but also with physical models and often one-to-one models, you know, like proper prototypes of the structure. The key aspects of this project were that the facade had to be transparent to allow natural light to fill the space. So you can see here, yeah. And then the structure at the back had to be something that could be easily built, but also taken down and rebuilt somewhere else. Because the issue that we have in London is that the price of renting anything is crazy. Everything costs a lot of money. So people that rent these arches, they often don't want to invest money to retrofit them or to do any sort of work, because the lease might end in 3 months, 6 months. And then what do they do with all the money that they put into like creating this space, yeah? So our project started also from a business point of view as a way to enable tenants to create a space, but that could be taken down and then moved in case their lease would end, yeah? So going back to the presentation, can you see me? Can you see this?
It usually takes a second to appear.
Here we go.
Yeah.
Yeah, so that's the vision that we had. And this is one of the arches built. Obviously, there was a bit of time that we needed to allocate to the R&D stage. So you don't get these sort of structures right at the first time, yeah? But we were relatively confident because we already tested the one-to-one and then it worked well. But obviously, working on sites in a tight space like an arch is not easy, because you can only access the top of the structure from the inside, yeah? So this is an image that shows how anyone could build this. Like if we can build it, like on the left side you see myself, on the right side there is Jonas with some friends and the client also. So we wanted to create a structure that could be built by anyone, you know, without having proper, like, any building skills or anything like that. So all the pieces had to be simple, easy to build, and also we kind of needed to have just few pieces. So it's like building Lego here, right? So you don't want 1,000 of connections. You want to have 3 pieces that are so easy that you understand how to build them without really checking, you know, how this should be done. In this case, we had the boxes that were supporting the outside wall, and then they were also creating the support for the long beams that were spanning from one side of the arch to the other. Again, this system is built without using nails, screws, glue. Every single component of this project can be taken down and used again. And this is a great value of this project. Because not a single money put into making these products would be like wasted. Even the insulation that you see on top is just rolled on the beams and clipped on the beams with some clippers that we designed and tested ourselves. Another aspect of this project is that because we designed every single part of this, we were able to customize the size of each part to be lightweight, easy to build, but also geometrically efficient in a way that these boxes fit a standard plywood sheet in a way that you don't have waste, yeah, or you minimize any waste that you can get, yeah. So we were like, you know, trying to focus on these aspects from the start. And the beams are spanning, in this particular case, around 5 meters, but we can span these beams up to 7.2 meters. And it's quite, I mean, it's a lot. 7 meters with just 2 sheets of plywood. It's not a joke, yeah. The beams are modular. Everything is modular, and they are joined with a dovetail joint that is secured in place with a long clip that we inserted. You see that the design process for making something like this was quite different from what we've experienced when working in large practices, because we were basically going from the 3D to the fabrication with one big step, because we were making it, so we were able to do this. Yeah. So you see here is a 3D model of the boxes with the system of how it has to be connected. So basically, you stack vertically a series of boxes, and then are stitched together with the connectors. And then on the 2 walls, you just need to make sure that the 2 walls are perpendicular, and you connect them with long beams secured in place. The connectors were also like the point onto which we were fixing the polycarbonate wall, because obviously in London it's quite cold, or it can be cold. So we needed to make sure that the space was like comfortable, thermally comfortable. So we were using like quite thick polycarbonate walls fixed on the structure to allow lights to fill the space, but also to create a wall that could provide quite a good U value. Yeah. This is the street of the arches. We built 3 of these arches, actually not 2. And then we've cut the pieces for the 3rd one that we will have to build soon. And now these arches are used. So in one arch there is a music studio, in another arch there is a carpenter. And as an architect, it's quite nice to see that at some point you need to let go and give your projects onto someone else, you know, to the client, and then to the tenant. Yeah. And you see how everyone customized this arch with their tools or with their things. And we often tend to work in this way, that our work is to create a system, and then anyone can customize and make it as they like. These are 2 details of how the beams are joined together, and then in the background you see the insulation that was like wrapped on the top. And we even had to design the doors, and yeah, we signed them with our logo, just to show that it was us. After a lot of work, you know, you really want to feel that, oh, this is going too far. This is going too far. There is a video that, here we go. There is a video here that I want to show you, which basically follows the process of the building of the arch from the start. I hope it will work. I will remove the music, it's a bit too loud, but yeah, you see how we started by having to, honestly, clean everything. And I didn't know that after studying six years and working 10 years as an architect, one day I had to do this, but like that was part of the plan, you know, like you sign up for this project, you prove that you can build it, and then as part of this competition, we had to physically build it, yeah. And you see that we are laying down the base for the arches. The base has to be raised from the soil so there's no damp coming up. And then on the top of this base, we were laying all the boxes, and honestly, you can build all these in a couple of hours, yeah? All the boxes are put together with just a mallet, so you don't need any special tool or anything strange. And the structure is quite strong, so we were building the architrave by like hanging it on both sides and then fixing it at the center. In the end, you see, the structure is quite a strong structure, and it's also flexible because obviously everything is built with zero tolerance, but still in between pieces there is a margin of tolerance that allow this to be flexible. Also, if you need to push it or like move it slightly on site. These are the long beams, and then you see here the insulation going in. Obviously, it was a sort of like an R&D process where we were like trying something, and if it didn't work, we were lucky that our factory, I mean our factory was next door, so we were building everything in another arch next door. So it was literally our workflow was like, you design something, you go next door, you try to build it. If it doesn't work, you go back, you fixed it, and then you built it, you know? So, and this process was kind of interesting, you know, because you end up knowing every single secret of the business that you are working on. And also you're responsible for it if it doesn't work, but like, luckily everything worked fine. The third project that I want to show you today, sorry if I'm rushing, but I want to be able to listen to all your questions, is my room in the garden. We started this project, we worked on this theme of creating a home office pod or a garden room in 2016, when we developed a project called Minima Moralia. There was a sort of like a portable pop-up studio for artists. And then when COVID happened, we felt like, okay, this is not great, but what is good is that, most of our projects stopped, obviously, but we were trying to focus on what to do next. And we were like going back to this project and said like, oh, this space, this kind of spaces are now needed for people working from their living room every day. So as I said at the start, in London, the prices for a space, either for rent or for sale, is quite crazy. And it's the same in many parts of the world. So we wanted to create an extra room that you can build in your garden or in any other space. Can be like a car park, you know, in any space where you can. And we were designing this like modular structure, again modular, that could be easily built, like self-built, in your garden, to create your extra space where to work or where to focus on your hobbies or passion. Yeah. So you see that this is the basic module that we built, was like 1.8 by 2.4. It's made of 3 modules, and we fit even a very small space like this one. This is like a London garden that is very, very tight and narrow. So this could not be used, you know, in any other way than just like having some flowers. Yeah. But what we did was like to go in and build the structure from scratch. And then you see here the modules of the structure that can host insulation in case you want to have it insulate. And then onto this, you can wrap an external layer to create a waterproofing layer. Yeah. So what we wanted to do was creating a series of modules that were like customizable, so everyone can use the space in the way they want, but also easy to build. You can see here, like you see the process of how easy this is. You start from an elevated base that sits on plastic risers, and then you fix together the modules, you wrap them with the polycarbonate sheets, and then fix the door, and job is done. Yeah. We think that as an architectural practice, knowing how to make things is important, and working modular is the way the future, I mean, is going. Like, you need to create projects that can be built in a clever way and that can be used in multiple ways. Yeah. And building with this system that kind of allows you to create something sustainable, but also something that can be built multiple times. Yeah. But we often stress that each customer, each client, each user of the space has to feel free and has to be able to customize this and change it. So instead of having the pegboard, you can have a mirror, you can have a finish of any kind, you know. So in this way, architecture is not something that we kind of dictate. Yeah, we just create a system for the people to then use them in the way they want. So this is all like a flat pack system. Everything is modular. You can choose to have like a window or like an opening or a solid panel, and you create your own space. Basically, you create your own room in the garden. I finished with this video as the last thing I'm going to present today. It shows the full process of how we do this. This is Jonas in the workshop. We are manufacturing pieces, and this is the corner of the structure that you can bend. So you basically cut grooves so you can bend the plywood. And then we were developing a one-to-one details with the metal, yeah, with the welders. So we could design every part of this structure in detail. So we went there, we discussed things, then we finalized details, and then we actually built the first prototypes. Everything is designed to be not too big, so you can move it inside tight spaces. You know, London can be quite, I mean, you can find quite narrow flats where you have to go up and down the stairs. So every piece is not too big and not too heavy, so you can like build it easily. Then you combine them together on site by using just a mallet and an Allen key, and then you lay the external cladding, finish off with the doors and everything, and that's it. That's your space. And at the time with this COVID, and I mean, it's kind of key for the well-being, for you know, for the mental health also of all of us, to be able to go out and work somewhere else. You cannot just work from your living room. You know, you need an extra space. You need something different. You need to step out. So we thought that working on this project at this time was kind of key to do something useful as an architect or as maker. And again, everything can be built by just using this and this. So anyone can do it, really. And I don't want to take too much time. I think I already spoke too much. Sorry for that. So if there's any question, I'm here and happy to answer.
Well, thank you, Tommaso, for this wonderful presentation. I mean, if we had at least another hour, I would have loved to see more of the project. I think the relevance of your, let's say, your webinar is very vital, especially in this time where we have COVID. There's a lot of financial crises happening around the world. A lot of people are actually aiming to refurbish existing spaces instead of building new spaces. So I think it's quite relevant to the times that we have right now. So I'll start asking you the Q&A questions. I'll start with the first one because there's a follow-up question to it. From Basim Mardini. What is the foil-like material under the arch above the plywood structure?
Yeah, I don't know if I have it around me. Maybe not. So basically, it's an insulation that is a foil insulation. You can find it in the UK as a method to insulate lofts or like roofs where you don't have a lot of space. So it's a series of sheets of aluminium and foam, and it's very lightweight, and it performs very, very well. It's able to basically create a comfortable space by being just like 20 or 35 millimeter thick.
So his follow-up question. Oh, okay.
Let me see if I can. So you see, there are lots of layers inside, and all these layers they trap condensation and the cold, basically. Yeah. So you insulate your space with this foil.
Okay. So the follow-up question was, and how do you get these structures water or weather tight?
Yes. Well, it depends on the project. In the arch, what we did is like on top of the structure, so on top of the beams, we were fixing the insulation that you just seen. And then above, there was just a layer of EPDM, which is like a rubber sort of plastic. That is what you use for roofs. So it's like the same component that you have in a normal roof. We just laid them on top, and they were like fit in between the arches, vaults, and the structure. For the other projects, it depends. The pods that we have built for the COVID, for the home office units, they are wrapped with a polycarbonate sheet. So polycarbonate is actually UV resistant for 10 years. Obviously, because it's plastic, it works well with certain climate, and it doesn't really work when it's too warm. And when it's warm, you just need to make sure that you have lots of natural ventilation inside. Although, yes, it kind of creates that waterproof layer. Yeah, that's you were asking.
Okay. Next question. Hello, the presentation. This is from Sabrina Bashir. The presentation is really interesting so far. I was wondering if these structures have any load-bearing capacity. If yes, how much? Or are they just designed to cover opening or as fillers in spaces?
Well, thank you for the question. I hope the presentation was interesting to the end, not just up to that moment. Yeah, so basically we work closely with engineers. To be honest, often we end up prototyping things even before we spoke with the engineer, because we ended up knowing a lot about joineries and how everything works. So we do one-to-one tests. Honestly, we just like sit on it, see how it bounces and how strong things are. And then we collaborate with engineers to sign off structures, basically. But if we're talking about plywood, there is, I mean, you can match the same load bearing of a standard floor made of timber joists. I mean, like working with plywood is like working with wood. So I would say that a standard floor in the UK, I think it has to be like, you need to hold 150 kilos per meter. So you can work out the structure and the size of it to kind of hold that much, yeah. So it really depends on how you design things, but the material itself can be used to create structures even on multiple levels.
Okay, and I think the follow-up question was, are they just designed to cover openings or as fillers in spaces? I think this question is more like what you as Boano Prišmontas would recommend, I guess.
Well, no, in that particular case, it worked well as a filling system because it was part of the brief, really. If you want to have a freestanding units, you just, I mean, look at what WikiHouse has done, or like there are other companies and other designers that kind of explore plywood. It's not just us, basically, but you can use plywood structures to create freestanding structures that they can be outside. Yeah, you just need to basically find a way to keep them dry. Because obviously by being plywood, you cannot really expose it to weather. And then the other issue that often you have is fire, but you can comply with the fire regulations by either using fire rated plywood. So it's a plywood that is impregnated with a chemical that kind of protects it from fire, or you can work out what's the minimum width for it to set on fire slowly enough for the people to evacuate, you know. So there are ways, but like plywood is definitely something that it's very strong because all the fibers are laid on different layers, and they are like laid oriented in different ways. So it's a very strong way of building things if you build it correctly.
Okay, we have a question from an anonymous attendee, and it's actually in reference to what you said about if the wood material is durable in rainy seasons.
Yeah, well, it is durable in rainy season. I mean, like you kind of expose it to water. What you can do is to treat it, but then it's a matter of costs, because if I create a bespoke furniture, like I don't know, a desk or this furniture here, yeah, you can treat it with some varnishing, and then they are resistant to water. And there are also some varnishes that are like for external use. The only issue is that it changes the color, becomes a bit more yellowish, it's not that nice, and still I wouldn't leave it exposed to the weather for 10 years, you know? So it really depends what you're trying to do. But like what we like to do is to create the system, the structural system, often by using plywood, but then the cladding has to be something else.
Okay. A similar question, and this is related to, is plywood as a material a good one, or can it withstand humid climates?
I thought that you were from Middle East. I mean, like, what is humid
I'm just telling you the questions everyone's asking. I might know, but you can say it too.
Yeah, no, of course there are different grades of plywoods. There are, yeah, you can treat it, but yeah, I wouldn't advise to expose plywood to humidity or direct water. Yeah, so the arches. The project that we built in the arches, the arches are extremely damp, but by having layers of insulation on top and the EPDM layer, you secure that the inside of the arch, the structure itself, is absolutely dry. Yeah, so that's fine. And you can also check the the humidity level inside the plywood. There are some sensors, so there are some very easy tools that you can buy from Amazon, are like 20 pounds, and you can see if the plywood is too damp or it risks like mold formation or not. So obviously you need to do a bit of a maintenance, like, you know, care about the space, but you can build it in any climate, knowing that don't expose it to actual rain.
Okay. Well, the questions are mounting up, by the way. Okay, so another question from Sabrina. She's quite an active question poster. My room in the garden. Can we integrate plumbing or air conditioning facilities into the system form?
Yeah. Yes. So we have just launched My Room in the Garden. We got lots of people interested. So what I've shown you is kind of based on UK, but we are now developing systems. We are now developing a solution to upgrade the system to meet any climates and integrate, you know, a space for planning, for electrical cables, virtually for air conditioning. So because you just cut plywood to the shape that you want, yeah, I can design something that has this shape, or can be fully full with a hole, and inside the hole I pass a cable, you know. So you can design what you need, basically, and that's a wonderful freedom to have, you know. So yeah, can be done.
Okay. Next question. You said, this is from Fatima. You said that the structure is joined with no glue, nails, or screws due to zero tolerance. However, is it possible to build a prefabricated modular unit as a vertical building of almost 10 floors using plywood material? If not, what material would you recommend as a material which is affordable for the design of modular units on a vertical building?
Yeah.
That's a tough one.
Well, that's a tough one. I mean, don't take my word and start building something and then blame on me if it doesn't work. But there are ways of building even multiple floors with plywood. Obviously, it's a matter of designing the right size, the right section, and you can use plywood. This is 18 millimeters. There are also plywood that are thicker, 24. It's always like a balance of if it makes sense financially, but also like in terms of construction methods. You just need to work with your engineer and ask how much we can stretch this, like how far can we go. The problem with the 10 floors is that 10 floors is quite tall, and you have lots of wind that pushes it, and plywood is strong but it's quite flexible. So I wouldn't envisage some problems, because it would move. It might not crash, it might not go down, but it would move, and you don't want to feel that your room at the 10th floor is floating, right? So, but there are different ways of building with wood that can be used for vertical heights. So there is CLT timber, which is cross-laminated timber. I've recently seen online that in Norway, they built the first not skyscraper, but like vertical building, all made of wood. So it's definitely something that's is now being explored more and more. But I wouldn't just use plywood for 10 stories. That's a bit too much.
I'd be worried. So from a question from Chris, for the room in the garden, how long is the production fabrication of the modular pieces? And basically it won't work without the CNC machine.
Yeah, so my room in the garden is designed to be cut with a CNC machine in order to create a system of modules that come in a flat pack, are quickly built together, and then assembled on site. Without the CNC, the closest things to that would be using some joists, screw them together, but what you would not have is the precision, and it would be quite a long process. So if you ask like a normal like builder that knows how to work with wood, they would just like screw everything together and they can build whatever you like, but without the level of precision, efficiency, and that the digital fabrication can offer. And how long does it take? Well, it doesn't take much, depending on the machine that you have, so how fast it can cut, and depending on the size of the room that you want. So you cut different modules. And for this sort of projects, what is key is actually having some stock ready. So if we get orders, we make sure that we have already cut 12, 20, 50 panels so we can deliver on time. Some components are not made by us, so we make the structure and everything that is plywood basically. And but some components, they come from other companies, like I don't know, the plastic or the windows. So there is a bit of time for them to ship their products to us, but like again, you work it out by having a bit of stock and then being able to deliver these structures. I would say between 4 to 6 weeks as a general time, yeah. But again, depends on the structure that the customers are buying, if it's small or big.
So a question that's actually related to what you were saying. Speaking of the future, do you think of a time when the components of these structures can be 3D printed instead of being made from plywood?
Yes. Well, it's already done. There are many companies that are working on 3D printing. We do have a small 3D printer here, but the problem with 3D printing is reaching certain size and do it on site. So there are some amazing companies that are testing concrete 3D printing. But at the moment, the issue that you have is that it costs a lot of money to set it up because you are the only one doing it, yeah? At some point, there will be like a critical point where that's the standard and everyone does it, and then it's gonna cost less. So that's why I don't see 3D printing being done everywhere, but it's definitely something that, it's one way of building future buildings. Plywood is another. So they all work with digital fabrication. They all work with the modern way of building, and it really depends on the project. So I've shown lots of plywood, but that's not the only thing that we do. Yeah. So it depends on the project. Obviously, building with plywood is kind of cost effective because, at least in Europe, plywood doesn't cost too much compared to other systems. And if you pre-design and pre-assemble certain components, you save on the cost of labor, like people that have to build things, yeah? So, for instance, the pot is something that we pre-assemble. So when it's on site, you just need to tighten it together with an Allen key, and it's built. So it's always a balance between efficiency and costs, building costs, material costs, and design also. Like if I want to do something that has a crazy shape or something very curved, probably 3D printing would work better than using plywood, but every project is different. What is interesting is that we are all trying to set a new standard for the future way of building. And that can be done in different ways.
Okay. My question, this is from Caroline. My question is for the garden space. What did you use as a footing that is acting as a foundation for the cubicle?
Yeah, because my room in the garden is not a heavy room. It doesn't need a foundation. So one key aspect was to create something that you can quickly build, and without asking for permission, planning. So one way to do that was, instead of having foundations that are drilled or dug in the soil, we just use adjustable risers. So they are like plastic risers of the light that you can use for decking. And these allow you to build something that is at a level, it's perfectly straight, but elevated from the soil. So you don't have any damp or anything any contact with dampness, water coming from the soil. So adjustable risers, which are the same actually that we use in the arches. Yeah.
Okay. So this is quite a heavy one.
Oh God.
What does the future of this is from Zahra Raisi, what does the future of the modular industry look like? Right.
We had a conversation today actually about this with Neil Hayward from the University of Cambridge actually. So we were discussing where this modularity craze is going in architecture, and we were looking at examples in Japan where the future of housing is going to be not that different from buying a car. You know, when you buy a car nowadays, what do? You know how it looks, how much it costs. Then you go, you try it, you see it, and then you buy it and you add accessories depending on, you know, luxury finishes or like the stereo, the whatever. And the future of the modular homes could be something similar, because once you have defined a system, a modular system that can be built multiple times, essentially you have a product that is flexible to be adjusted and to cover different scenarios. And modular housing is like the next step. You're going to be able to have a catalog and choose the kind of house that you can build. And then, and that's where I think modularity is going on a ontological, or like, I don't know, on another level, which is more about design and composition. You can debate if modularity is a trap where you end up doing the same thing, and if everything is obsessively modular, where is the beauty of our building? We think that modularity needs to be like a sort of an attitude, you know, try to do something that makes sense, can be built multiple times, is cost effective, and can be customized. And the creativity of that is in the type of system that you set up. So you don't dictate the aesthetic, but you create a clever system. So there is a lot of, that's a lot for the creative process, yeah? But obviously, you need to create something that is like, with a margin of freedom. Otherwise, we are just gonna live in boxes, which is not nice, you know?
Yeah. This is actually a question from me. If I recall, you guys are also looking into utilizing the dust waste from the CNC machines, correct?
That's true. That's true.
So maybe you can quickly touch on that, because I saw it on your Instagram, but I wasn't sure where it was going.
Yeah. So because we have a workshop here, we produce lots of waste that we don't know what to do with. We don't know how to use it, basically. And we feel that it should be used. Even if our waste is just wood, yeah? We feel that once you feel like a huge bag of plywood dust, that's something that could be used or should be used in a better way. So we've worked with a mycologist, Ashley Granter, from a company called Natura Studios. Mm-hmm. And we developed with him a way to, I know that it sounds crazy, but it's actually real, to grow mushrooms that eat our plywood dust. Yeah. So what you see here is actually our plywood. Yeah. This is when you cut lines, you often have like these sort of strings of plywood that they come out. Yeah. And if you put them in a jar or in any mold, yeah, there is enough air inside for a mushroom to grow and eat the plywood and create this sort of very dense structure that creates a bond between the plywood and the mushroom itself. And you create a board that then you can use. So there is quite a lot. There are quite a lot of interesting companies that are trying to develop different ways to use mycelium. It's called mycelium. Different ways to use mycelium in the packaging industry, for acoustic insulation, for building insulation. So there is a movement out there that is trying to reuse wood, mix it with mushrooms, and create something interesting and useful. So we are working on that. It's already quite interesting because we train the mycelium spores to eat the glue of the plywoods, because obviously inside plywood there is some glue that it would be toxic. So we train them now, and now they're able to eat that, and that's quite great. So what we envisage in the next year or so is to actually not waste any of our plywood dust and transform them into something else that can be used again.
Complete the cycle of use.
Exactly.
Very nice. We have 3 more questions. So thank you again for staying a little bit longer just to answer them.
No, it's fine. Thank you for all these. I mean,
of course.
It's great. Thanks a lot.
So this is another one from Fatma. And it's going back to the vertical building question.
Okay.
Is it possible to build the units as plywood and integrate with another material to ensure stability? If yes, what other material would you recommend to ensure stability that is also affordable?
Okay. Well, I think what's challenging here is defining affordable, because what do we mean with affordable if we're talking about a high-rise building, you know? Yeah. What's the price range that we are aiming at, basically? And also it depends on where we are in the world, because for instance, in UK, building with steel, it's quite okay, and doesn't cost that much. If I have to think about Italy, where I'm from, don't use steel, it's all about concrete. If I think about Norway, not steel, not concrete, all about wood. So it really depends on where we are in the world. But it's true that you can create a strong cage and then insert the rooms as if they are pods. They are pre-built somewhere else. So the facility, the process should be like this: that you create a skeleton, and in a separate facility, you prefabricate your house units, and then with a crane, you just like slot them in. Yeah, and that's it.
So and you'll have like an idea of a shell and core building that has all the provisions, and you just insert and plug in the provisions into each pod. That would be actually a really cool idea.
Let's do it.
Yeah. Okay, next question. When it comes to structural strength, this one is kind of unclear. When it comes to the structural strength, how is it regarding to its stability and strength analysis? So I think this is more of a engineer question of how you define the plywood strength and stability.
Okay, I'm still a designer or an architect, and I'm not an engineer. But
right,
I can tell you that like plywood is quite strong. Okay, plywood works in this way. If it's like this, and it's very long, it sags at some point, So if it's placed vertically, you have the shear force inside the structure that is like actually provide quite a good. I mean, it's quite strong, and you can then layer up more sheets to create a stronger unit, or you can increase the height of the beams or the structure to make it even stronger. So by working with these two elements, the section and the height of the structure, then you can create a structure that is actually quite strong. We are now working on a house here in Hackney in London, where the client has a basement and the ground floor, and the basement is a bit tight with space, with head height. So we stripped out the whole ground floor, And we're going to develop a system that we tested last week of replacing the existing floor that is built in, standard way with steel and joist with just a plywood floor. So we did a span of 6 meters, and we are now working with the engineer to understand, what's the spacing of each element and how big these elements have to be to provide the same structural stability of a standard floor. Yeah.
Okay. Two more
I hope
questions.
this kind of answer questions. Otherwise, I can forward you the email to my engineer, and then we can work it out.
Okay, so if it's all right with you and Jonas, I'm going to. I mean, if you give me the green light, I'll post for the attendees your email that you have actually on your website, the hello@Boano Prišmontas, so that the attendees, if they had any specific questions or any ideas in mind, they can pursue them directly with you.
Yeah, that's absolutely.
Last two questions. Since the world is undergoing drastic climate change, what would be your insight with regards to structural designs? What innovations would you recommend? Thank you. This is from Renz.
What do you mean elevations? With elevation?
Innovations.
Innovations.
Yeah.
Well, that's a long answer. Wait, I need to structure it in a way that doesn't take half an hour. So okay, there is COVID now. Yeah. No one is happy with that.
Right.
Obviously, it's been quite sad, quite tragic for many, and obviously, as every time a crisis happens, the whole world tries to find a way to bounce back. And I'm not going to say that design will save the world or anything like that, because COVID has to be treated seriously by who's working every day in hospitals. And so, but like what we can do is just adapt our way of making things or making spaces to something that complies to a different world, the world that we are living in today. So what saddens me is that in our industry, COVID kind of meant that everyone is going to use plastic again, much more than what it was, which is probably not the right way to do. Obviously, hopefully, this crisis is going to end at some point. But even if it's going to end, I think it has left an impact in our minds. So our minds have been impacted by this crisis. So thinking modular in a way is something that COVID is pushing more, because you've seen lots of like modular pods in restaurants, or like replicable small spaces that can be controlled or can be like sheltered. Yeah. So in a way, probably COVID has pushed that a bit. And then, yeah, it's difficult to predict what's gonna happen. But one way could be also that we increase with the level of how we sense the spaces. So like, there is this thing about sensing architecture. So you have sensors everywhere, yeah, tracking everything. So one way that design and our industry can be affected by COVID is actually that we might possibly oversense the space that we are building to track, how many people are inside, or like what's the spacing between people, or like, all these things could be something that's are going to be the way we build tomorrow. But I'm very sorry for whoever is building an office tower in London, because that's not going to work. And I'm very sorry for whoever is investing a lot of money in the conventional co-working space kind of stuff, because that's not going to work. Yeah. So it doesn't mean that we cannot convert these spaces into something else. Imagine that, like my room in the garden, instead of being placed in a garden, we can create a series of personalized small studios where everyone can work in these studios. And it can either be in your garden, or it can be in an office tower, yeah. But all the spaces have to be secluded a bit more than what they were, yeah. So anything that is like a shared table or a shared space or anything shared at the moment not working well, which I mean is not great, but that's what it is.
Okay. Last question from Jean. Using plywood structure systems is not an environmentally friendly solution. How is that considered in the field of eco-friendly architectural solutions?
Well, it depends what you mean with not environmentally friendly, because of course, let's not pretend that everything is 100% sustainable in a way that you leave no trace in the walls. Yeah, anything you do leaves a trace. What we need to think of is like it's more environmentally friendly than something else. Yeah. So if you compare concrete versus plywood, plywood is better because it's about wood. The wood is certified. Is all the wood that we use comes from forests in Europe they are expressively growing to manufacture wood, and so I mean it's better than steel. It's better than concrete. Obviously, it's not absolutely perfect, but there's nothing like that. You know, when they tell you that something is completely, absolutely green, eco, bio, sustainable, is never 100% true. So we think that what's good about plywood is also the fact that by using the plywood in the way that we use it, we size things in a way that we don't waste plywood. So we get a sheet of 1.2 by 2.4. We use every single inch of that to make something. Yeah. So there's no waste. That's the best we can do, probably. I don't know. I'm sure there will be better ways in the future, but like I'm quite happy of using plywood at the moment. Okay,
we were almost done with the, okay, never mind. They're just asking if this is going to be uploaded on YouTube. It's so basically everyone, to all the attendees, we typically upload the talks on YouTube after we get the approval of our presenters. Okay. So once we get a formal approval from them, then it's accessible on the AIA Middle East official YouTube channel. So that's the end of the Q&A session. I just wanted to thank you again, Tommaso, for making time. I'm sure like the time differences is a bit weird. And I thoroughly enjoyed it and hope to see more projects and perhaps maybe projects here in the Middle East.
Of course. Of course.
Fingers crossed in Amman. And we hope to see you in other talks, hopefully in the future when you have other exciting projects that you can talk about. To the attendees, I had put Jonas and Tommaso's joint email, which is the one that they will probably receive queries, or if you're interested in a future project or something along these lines, you can contact them. They're busy bees. They have a few projects in the pipeline. Yeah, and that's it. Any closing comments, Tommaso, that you'd like to give to the attendees?
I want to thank you, Mariam. Thanks the AIA. Thank everyone really that's listened to what I had to say, and also put forward so many interesting questions. Yeah. So well, again, thanks a lot. It's good to know that even in these times of crisis, we are still able to share things and work for I don't know, creating something interesting for the future.